So now I'd like to tell you about how I like to think about molarity calculations, which is kind of related, which is related to what I've just shown you, but it's not really an equation as such that I use. But let me show you. So we've got to remember that if we write 1 molar, 1 capital M, that means that it's 1 mole of substance per litre. So what I like to do is I write out this sentence, and we know that 1 mole, the mass of 1 mole is the molecular weight of the given chemical in grams. So molecular weight, grams of our chemical, any chemical, in 1,000 mils, or 1 litre, gives us a concentration of 1 molar, or 1 mole per litre. So what I like to do is I can change two of these things at once. So for example, if we want to change the mass and the volume by the same proportion, so I'm going to write times P, this is just a number, any number, and we can work out P based on the volume or the mass that we want. I'll show you an example in a minute. So here we've got the same concentration, but we're changing mass and volume. So let's imagine we're adding less. We want less chemical, but we want to keep the concentration the same. Then we need to have less volume for the chemical to be in order for that to happen. And similarly, if we want to change the mass and the concentration, let's say times Q, so this is again the number we work out based on what we're aiming for, then the volume stays the same. So if we want to, let's say we want to add more mass in a constant volume, then the concentration will increase based on compared to our molar concentration. So here we've got the same volume, but we're changing the mass and concentration by the same amount, by the same proportion, by multiplying by the same number. So let me show you an example to show you what I mean. So for example, I want 15 mils of 100 millimolar solution of NaCl, and I want to know the mass of NaCl I need to add. So first of all, I use the fact I know that the molecular weight of NaCl is 58.5 grams. So 58.5 grams of NaCl in 1,000 mils gives 1 molar. But I don't want 1 molar, I want 100 millimolar, which is the same as saying 0.1 molar, because there are 1,000 millimolar in 1 molar. So to get from 1 to 0.1, what do I have to do? I have to divide by 10. And so I also have to divide my mass that I add by 10. So it's going to be 10 times less stuff. So it's going to be 10 times less concentrated in a constant volume of 1,000 mils. So that gives us 58.5 divided by 10, or 5.85 grams of NaCl in 1,000 mils, gives us 100 millimolar. So now we want to change the volume. So we've done this part. Now we want to change the volume and to go from 1,000 millilitres to 15 millilitres. So if you do 1,000 divided by 15, it goes 6.6 recurring times. So to go from 1,000 to 15, I have to divide by 6.66. So I also have to divide my mass of salt by the same amount. So here I'm changing the volume and the mass by the same proportion so that I can keep my concentration the same. So 5.85 divided by 6.666 is 0.878 grams. Okay, and so that's our answer. This is the mass of NaCl that I need to add to 50 millilitres to give me a concentration of 100 millimolar, or let's even change that into milligrams. That's 878 milligrams, and that is my final answer.